Okay, welcome to 1-3 video for algebra. First, we talked about, yesterday yesterday meaning Friday, that function notation, that f of x, we say it f of x, and it represents the dependent variable, and it's the same thing as y. So instead of saying y equals an equation, you can rewrite it as f of x equals. Okay, so if you have y equals an equation, you can change it to f of x equals. Okay, be careful on your homework, because on your homework it is, let's see, I gotta go to it. Let's pause this. Let's say number 4, for example. You've got L equals absolute value of n minus 2. Well, when I write this, I can't write f of x equals absolute value of n minus 2. Don't write that. X would be wrong. X is wrong because that's not the variable we're using over here. We have to use the same variable that we used in the problem itself. Shrink this down. Okay. So you can say f of n. Has to match variables. So be careful of that on your homework. And don't get too worked up in this section about what the different equations are. Okay, next part. I had you go through your functions and look for functions that were increasing and decreasing. Increasing, decreasing, and constant. Alright, so we looked at the combination of decreasing and constant. We put those in this category over here, but for the first part of the activity, these are the graphs we really needed. Okay, and here's a picture of them. G and K, H, L, O, and P, those are all decreasing, and U is a constant function. It's going straight across. So increasing, decreasing, and constant. Then we went in and typed things into the calculator to match the graphs. So these are the equations that make all those graphs. So for example, I could go into my calculator, go into my y equals menu, and type x. For f of x equals x, that's the same thing as y equals x. So I can hit graph. I would get that picture. And that's the same as graph G. They are the same. So that's what we were doing in that section of your book. One thing I taught you how to do in this area is how to do fractions. So like the next one, f of x, clear it out. To do a fraction, first of all, if I see parentheses, I should type them. So parenthesis, the fraction is in a hidden menu. Alpha, y equals. And we get numerator over denominator. So I'll hit enter because that's already lit up. And it made a fraction for me. So I will type 1, then arrow down and get 2. And now I need to arrow out of the fraction so that I can make my other parenthesis. And then caret to make my exponent of x, x. I also need to arrow out of the exponent so that I can make the minus 5 look normal size. If I don't arrow out of the exponent, it would make that minus 5 in with the x, and the graph would look very wrong. And we get this graph, which matched up with H, okay, with H. So we went through and we typed in each equation that we have here and matched up the pictures. Okay. Then the next part of the lesson was to take the same graphs and sort them differently. Okay, so let's look back at those for a second. We're going to sort these differently now. Instead of increasing, decreasing, and constant, we're going to group them by, I'll use informal words first, straighties and curvies. So there's a curve, straight, straight, curve, and straight. Okay, so these functions here are all straight lines, and they are linear. Whoops. Linear. These functions here have a name. They are called exponential. Okay, these are exponential functions. Okay, the ones that are curved and appear to have a flat area. When we talk more in depth about exponential, you'll learn that they don't really have a flat area. But that's those two groups. And these are the linear ones. These are the exponential ones. So in your homework, you're asked, as part of your assignment, to find linear, exponential, plus some more function families that we haven't talked about yet in the video, but we talked about in class. Okay. Next, we looked at this vocabulary. A function family is a group of functions that share certain characteristics. So the family of linear functions are lines, and they are in the form f of x equals mx plus b. Exponential functions include functions in the form of f of x equals a number times another number with an exponent of x. Okay, the next thing that I had you do is go through the graphs and pick out all the ones that have a minimum and a maximum. A minimum would be a lowest point on the graph, has one lowest point. A maximum would be a one highest point on the graph. So if we do that, these are all the graphs that have minimums, have a 1 point that is the lowest point, that has a low point, that has a low point. Those are called minimums. These graphs go up, turn around, and come down, and that turnaround point in general is called the vertex, so that point is called the vertex, but when it's a topmost point, it's called an absolute maximum. Even a discrete graph has a maximum, and a maximum, and a maximum. So the next thing we did was go through on our calculator and type all these things in. I'll do a couple just to show you. So y equals x squared. Keep in mind, squared is an exponent we use so much it gets its own key, plus 8x plus 12, and then hit graph. Okay, and that matched up with graph T. Graph T. Okay, the next one is the one that students had more difficulty with. Okay, because it has these straight up and down bars, those absolute value bars. And there isn't a clear-cut button of where those are. Well, you find it in the catalog. So to get to the catalog, it's above the 0 key. So we have to hit second, catalog. And ABS is the very first thing on the list. I don't even have to scroll to find it. And it's absolute value. So you hit enter. And see, it makes the bars for you. So then you can just type x minus 3. Now we have a minus 2 outside the bars, so we have to arrow out of them and then click minus 2 and graph it. And we get this V shape, and it ends up being graph V. Okay, graph V. So once we put all those into our calculator, we have them all matched up. Okay, now we're going to rearrange these functions. All right, we have them first sorted by minimums and maximums. Then we're going to resort them. This time I'm going to save the right vocabulary word for just a minute from now. We've got V shape and we've got a U shape. Okay, so we're going to put the V shapes over here and the U shapes over here. Okay, so now we've separated them by shape instead. These U-shaped ones are called quadratic. These are quadratics. And these guys over here are absolute value graphs. Now the book refers to them as linear absolute value because they make V's with lines. That's all we really talk about in this course. We don't do absolute values around exponents or anything like that. So they're all, I will often shorten linear absolute value to just absolute value. Okay, so those belong in a function family together. The quadratics are one function family. Those are your U shapes. And your linear absolute value, those are your V shapes. Okay, it could be an upside down U or a right side up U. Quadratics have an exponent of 2 to go with the x. A, B, and C, remember, are going to be numbers. They're not going to be A's, B's, and C's. And then absolute value symbol functions have the absolute value symbols in them. They're easy to tell because they have absolute value in them. Alright, then we have these things look really complicated. There's f of x, and then there's 3 things, or sometimes 2 things in brackets next to it. And then there's these inequalities. These things are called piecewise functions. These are called piecewise functions. Again, right now we're just calling them linear piecewise functions because these are all linear. But we can make a piecewise function with any kind of function, really. Alright, and here's what they look like. They're those ones that seem to just change direction. That's because we're graphing one piece of a line, then we're graphing another piece of a line, and then we're graphing another piece of the line all on one graph. So we're graphing pieces of things and connecting them. And that's what piecewise is. So on your homework, okay, this is multiple choice. It is easier if you have a calculator because then you can just type this in. However, if you don't have a calculator, it's okay. Kind of. It's harder. It's easier if you have a calculator. And I would recommend a pre-signed pass to my room to use a calculator if you don't have one. So if you are really good with your vocabulary and you know this is a linear equation and this is an exponential equation, that one's out. And then if you remember from last year that 2/3 is a positive slope and I should have an uphill line, then you can eliminate graph C. And I didn't have to type it into a calculator. But it's lots easier with a calculator. Lots easier. So I highly encourage you to have a calculator, or to get a pre-signed pass if you do not have a calculator to use at home, to do just this section. It's only 6 questions. The front of this page, whoops, too fast. 7, 8, and 9, and 10, 11, 12. The rest of this is really how well do you know your vocabulary. So for example, it says determine whether each graph represents an increasing function, decreasing function, constant, or a combination. So you're just writing a quick sentence for each one. Don't overthink it. In this section, determine whether there is a minimum, a maximum, or neither. So number 19 has a minimum. It has a low point. Number 20 is linear. The arrows go up and down in both directions. There is no low point. There's no high point. This would be a neither. And 21, we have a graph that goes up, reaches a maximum, and goes back down. So this graph represents a function with an absolute maximum. And the last section is your function families. You really, I can't emphasize enough in this chapter, need to know your vocabulary. A linear makes a line. Whoops, I want this one. A linear makes a line. Quadratic makes a U shape. Exponential makes that curve that, see, it goes up and then seems to flatten out. Okay? Absolute value function is that V shape. And piecewise is one that just kind of zigzags. A constant function, I'm not drawing a very good flat line here. A constant function is one that is flat. Okay, so you have to know your vocabulary in order to correctly and accurately do this assignment. Okay, tomorrow you have a vocabulary quiz. Keep in mind that in your textbook, and hold on, I'll show you. In your textbook, at the beginning of each section, they have these key terms. So here's some key terms that you need to know. Oh, more key terms that you need to know. And more key terms that you need to know. Okay? I will tell you that the quiz does not have every vocabulary word in it, but I'm not going to tell you which ones it does. And frankly, for the course of this year, there's no words in this list that are less important and can be ignored. These are words that you not only need to know for tomorrow, not only need to know for this chapter, but these are words you need to know for the year. So please make a point of learning these vocabulary words. Very, 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 very important. Okay? And as some of you were not aware of, let me pause again. At the end of your textbook, you have a glossary, and I expect you to be looking things up in your glossary. So things like absolute minimum, absolute maximum. Here's a whole definition and a whole picture to go with it to demonstrate that vocabulary word. So look stuff up at the end of your textbook in your glossary if you don't know your vocab. Okay, good luck. Again, if you need a calculator to do the 7 through 12 on the homework, come see me in the morning for a pre-signed pass. Otherwise, have a great day, and I'll see you tomorrow.